Okay, the purpose of this video is to walk us through the process of graphing an equation using the intercepts. So typically these equations are going to look a bit different. So this is an example. 4x plus 3y minus 12 equals 0. So we are going to find the intercepts in the way we've been exploring in the Desmos activity. To find the y-intercept, we know that that happens when x is 0. So I'm going to take this equation, and because x is 0 at the y-intercept, I'm just going to substitute x equals 0 on my equation here. And this is what I have. 4x, but x is 0, so 4 times 0 plus 3y minus 12 equals 0. You can see that this term is going to become 0 because any number multiplied by 0 is 0. And then I'm going to solve for y. And when I do that, I'm going to find the y-intercept. So here's the equation that I have now. Once I cancel that first term, it becomes 3y minus 12 equals 0. And then this is something we've done before. To isolate the y, let's say I'm going to add 12 to both sides. So then this 12 becomes a 0. And what I have left now is this new equation, 3y equals 12, which I can probably solve by inspection. 3 times a number gives me 12, so that number is going to be 4. So now we have the y-intercept. Okay, now let's find the x-intercept. And the x-intercept happens when y equals 0. So I'm going to do the same process, except this time I'm going to substitute the y for 0 in this equation. So I have 4x plus 3 times y, but y is 0. In other words, plus 3 times 0 minus 12 equals 0. So you can see that 3 times 0 becomes 0. And then this equation, now that I can solve for x, becomes 4x minus 12 equals 0. Okay, I can solve this. My first step would be to add 12 to both sides to isolate my x. And then I realize that that becomes 4x on the left side equal 12 on the right side. And I can also solve this one by inspection because I can see that 4 times a number gives me 12. So that number is going to be 3. Beautiful. So now I have found the y-intercept at 4 and the x-intercept at 3. Okay, so now I'm going to graph this. So this should be very friendly because we only need 2 points to plot a straight line. And just for recall, this is the equation we had. So I know the y-intercept is at 4, the x-intercept is at 3. So my line is going to go through those points. The y-intercept at 4, the x-intercept at 3. So that's how I graph a line of an equation that is in standard form, like this. I can also see, by the way, my rise, the run, and the slope, and the y-intercept for this line, if I wanted to put it in in slope y-intercept mode. But this is a bit different today. So this is one example. We're going to do another example. Here it goes. Similar idea, except we have a different equation. This time our equation is 2x minus y plus 10 equals 0. So, but the process is the same. We are going to find the intercepts, both the y and the x-intercept. So let's begin with the y-intercept. And to find the y-intercept, we know that that happens when x is 0. So then I'm going to substitute 0 for x in this equation. And I end up with this new equation, 2 times 0 minus 10, minus y, excuse me, plus 10 equals 0. All I did was substitute the x for the 0. And now this equation, when I solve for y, little by little, becomes this. Negative y plus 10 equals 0 because this term disappears, it's 0. So I can see here that I may want to subtract 10 on both sides to isolate the y. When I do this, on the left side, I end up with negative y, and on the right side, I end up with negative 10. So this is a bit, we've seen this example before, where we have negative y equals negative 10. That means positive y is going to be the opposite of this number, therefore y equals 10. And that is the y-intercept. Good. Now let's repeat the process, but this time we're going to find the x-intercept. So we know the x-intercept happens when y is 0. So the same idea, I'm going to substitute the y for 0 in my original equation here, 2x minus y, but now y is 0. 2x minus 0 plus 10 equals 0. And then I'm going to solve for x this time. So what I'm doing next is I'm going to write this equation, get rid of this term because it's 0, and my equation becomes 2x plus 10 equals 0. And you can see that to isolate the x, the first step could be to subtract 10 on both sides. And when I do that, my equation becomes on the left side just 2x equals negative 10. And you probably can figure these one by inspection. 2 times a number gives me negative 10. So the number I'm looking for is negative 5 because 2 times negative 5 equals negative 10. So now I have found out both the y-intercept and the x-intercept. So I'm just going to graph in my plane the intercepts, which is very, very friendly. The y-intercept is at 10, the x-intercept at negative 5. So my line will go through those two points. And that is my line with the y-intercept at 10 and the x-intercept at negative 5. Again, I can see this is the equation that I have originally. So this graph corresponds to this equation. This equation is in standard form. If I wanted to put this equation in slope y-intercept form, I could just do it by looking at it. And I can quickly see that the slope is 10 divided by 5, or 2. So I'm going to write it here in slope y-intercept form. The slope would be 10 divided by 5, x, and the y-intercept is 10. So these two equations are equivalent. This would be 2x plus 10. So these equations are equivalent. The equation in standard form and the equation in slope y-intercept form. What we've been focusing on, of course, today is this standard form, and we find that with the intercepts. I hope this was useful. Thanks for watching.